Identify conditional identities and inconsistent equations. It is not appropriate to substitute values in a given mathematical sentence to check whether it is an identity, conditional or inconsistent equation, because it may give a true result for some values and you may think it is an identity, but there are other values that you have not considered which make the sentence false. Therefore, it is better to find a general form of all these three types of mathematical sentences, then check which category the given sentence does belong to. It is clear that the general form of identities, after having made all possible operations, is shown in the following on screen. Where n is the order, highest power, of the original equation. In first-order identities, we have n equals 1, in second-order ones n equals 2 and so on. In other words, all variables, coefficients and constants become 0 after all operations and simplification are made. For example, we have the following as shown on screen. We have the following as shown on screen. Adding -3x and 2 to both sides to remove all terms from the right side yields, we have the following as shown on screen. Hence, this is an identity. On the other hand, if we have an equation that, after having made all possible operations and simplifications, we have the following as shown on screen. Where a and b are numbers, a is a coefficient and b is a constant, and b is a variable, then we are dealing with a conditional identity, which is nothing more than a normal equation, like those we discussed in prior tutorials. Such equations have a limited maximum number of solutions depending on their order and number of variables. Thus, the first-order equations with one variable have at maximum one solution, the second-order equations with one variable, quadratic equations, have two solutions at maximum, and so on. For example, 7x minus 21 is equal to 0 has a single solution, x equals 3, because 3 minus 21 is equal to 0. All the other numbers give false results in regard to the equality between the two sides of the equation. Last, if we have an equation that after having made all possible operations and simplifications gives a general form, we have the following shown on screen. Where b is a constant, then we are dealing with an inconsistent equation, i.e. with an equation that has no solutions. For example, 3x minus 4 equals minus 2x plus 1 plus 5x is an inconsistent equation as after doing the operations, we obtain the following shown on screen. Here, b equals 5. Example. Find whether the following mathematical sentences are identities, conditional identities, equations, or inconsistent equations. A. 2x minus 1, 2 equals 1 minus 4x plus 4x squared. B. For minus 3x equals 3 minus 3, x plus 2. Solution. A. When the left side of this equation expands, it has the same expression as the one on the right side as it represents the square of a difference, the second special algebraic identity discussed in tutorial 6.3. This indicates that we are dealing with an identity. Indeed, we have the following shown on screen. This is identical to the right side of the first equation, as based on the commutative property of addition, we have the following as shown on screen. Therefore we have the following as shown on screen. Sending all terms on the left side yields, we have the following as shown on screen. Which represents the general form of identity where n equals 2. B. Solving this equation yields. We have the following as shown on screen. Sending variables on the left and numbers on the right yields, we have the following shown on screen. This is an inconsistent equation, as it has the general form 0x equals b, where b equals -7. That is all for lesson 9.3.3. To continue this tutorial, please watch 9.3.4, 8 Algebraic Identities. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.